Good afternoon, everyone, and welcome to this session on leveraging advanced technologies and focus on data cubes. I will be pleased to present some recent advancement that we've developed in the frame of the Swiss data cube, and I will try to show how the Swiss data cube is trying to support the Swiss government in terms of policy making and policy advices. So my name is Gregory Giuliani. I'm a senior lecturer in Earth observation at the University of Geneva Institute for Environmental Sciences, but I'm also sharing my time with the UNEP, so the Global Resource Information Database, where I'm the head of unit of the Digital Earth unit, and I'm the Swiss Data Cube project leader. So if we look at the latest World Economic Forum report that came out in January, if we look at the 10 major risks identified by the WEF, for the first time, the first 5 top risk, I would say, are related to the environment. So it's a kind of, my point of view, kind of turn off point in terms of taking cautious about the risk related to the environment. So to look and to see how the environment is evolving through time. So we have plenty of satellites in orbits and looking at the Earth and taking images of the Earth. And if we look at the European Space Agency program, so the Sentinel program led by Copernicus in the European Commission, so it took approximately 22,000 images to cover the Earth. And it's doing that every 5 days. So it means that per year, it generates more than 1 million images per year. So it's a huge amount of data. And if we look at this picture, obviously the Copernicus program is now the largest EO data provider in the world. It distributes more than 250 terabytes per day. It stores more than 250 petabytes of data with all the satellites that ESA is operating, and the daily growth rate is approximately 220 terabytes per day. So it's a huge amount of data. And the question that we can ask ourselves is how we can transform this really large amount of data in something useful to support evidence-based decision and policy making. So in terms of sustainable development, I think the key for sustainable development is to find this right balance between what the nature can offer, so and the exploitation of the natural resources for economic development. So we often talk about ecosystem services or natural capitals. So that's the way to go and find this kind of good balance or equilibrium between the offer and the demand. And the big challenge in terms of evidence-based policymaking is obviously from the data that we generate and from the huge amount of data that we generate is to generate knowledge, obviously, from that, and then to support decisions. So basically the data are just signals, some measurements, unstructured. Then if we organize a little bit the data, so for example, from the data we generate a graph, we can generate some information. And based on that information, if we contextualize that information, then we can say that this graph is showing the increasing of CO2 emissions in the atmosphere or something like this. So it generates the knowledge. So it informs us about the limits of the planet. And then societies can decide how to use the limited resources of our planet. So it takes we can take actions and look at the impact of the decision on the ground. To that, to support that vision, we clearly think that we need to focus on result-based and open science or open data. Obviously, both the Landsat and the Copernicus programs are providing open data. Generate the knowledge also in terms of research through publications, through open access publication. Provide access to the source code, so using open source. Provide also open notebooks so that we can replicate the work that we are doing, and so on. So really, open science is the main, I would say, red line between all the work that we are doing in the frame of the Swiss Data Cube. So the Swiss Data Cube is an effort led by four institutions, so the University of Geneva, the Gregory Geneva, and since last July, it's also supported by University of Zurich and WSL, so the Federal Institute for Forest, Snow, and Landscape Research. So we are now storing data since 1984. So we have the entire Landsat 5, 7, and 8 plus the entire Sentinel 1 and 2 archive at different spatial resolutions. And if we say that one pixel is one observation, we store more than 1,000 billion observation over the entire country, which is a lot of information, potential information. And obviously the cost saving also is quite interesting. If you look that we're seated on a small treasure, I would say, in terms of monetary evaluation of the data. So just to show you how we use the Swiss Data Cube, this is just a quick example. So it's a mosaic over the summer months in 2014 using the Landsat satellite over the Geneva area. So it was I would say a common summer, not too hot, not too dry. And in 2018, we had an important drought over Switzerland, and you see now you can compare that. Obviously, the vegetation is a bit more brown, but if we compare it visually with the drought that we had in 2003, you can see that the impact of the heat wave that we have at the beginning of 2003 was much more important. Also in terms of drought, using a water detection tool. So this is a small lake between France and Switzerland. So that's the Lac des Brenets. And you can see this. So this is the lake in September 2017, and this is the lake in September 2018, where you can see that the water level has decreased dramatically because of the drought that occurred 2 years ago. So that's a way also to look at the impact on the ground of the drought. You can also use the Swiss Data Cube for monitoring urbanization. So this is the city of Bulle in 1985. So you're with Landsat data. And this is the same area in 2018 where you can see the urbanization, the huge urbanization of that city. It's quite famous because this is in that city that we have the Nespresso factory and sending all over the world the coffee made by Nespresso. Also the impact of climate change. So this is the Rhone Glacier. You can clearly compare also two periods over the same area, and you can see obviously the glacier that is shrinking, the snow that is disappearing, and in front of the glacier also a lake that is forming and that is still expanding. So it's a clear impact of the climate change. So to that, what we have done, we have developed a small atlas that we've called Atlas of Changing Switzerland, where users can use the Swiss Data Cube and explore different sites over the country, and in a manner of a kind of, I would say, before after. You can look, for example, at the impact of forest fire in that case, or this is the example of the Bondo landslide, where you can compare just before and after the landslide, and you can see the impacted area in this region of Switzerland. So it's an application that is freely available, and you have the URL on top of the slide. So you remember probably, and you heard that also we have assessed the snow cover changes over the last 20 years over the entire country using the Landsat data. So we have identified that permanent snow area have decreased of more than 4% around the country. And the good I would say sign of the tool that we have developed to look at the snow cover change is that now we are also using the same algorithm to support archaeologists to identify potential area of interest where they have to do their own studies. So it's not only the impact of climate change that we are here assessing, but also we can support other scientific community with the data that we have generated using the Swiss data cube. We are also using the Swiss data cube to assess land degradation at the national scale, and in that frame we have partnered also with obviously GEO, with the European Space Agency, CNR in Italy, the GRC, and UN Environment, so that we can develop a kind of, I would say, framework where we still use this data information knowledge pattern to assess land degradation in accordance with the SDG definition. So the indicator SDG 15.3.1. But the idea is to make the model as flexible as much as possible, so that users can use, for example, the Google Earth Engine, but also the Swiss Data Cube. If you want to work at the national level, you can access data directly from the GEOS platform, and you can even use the Copernicus diocese systems. So that's the idea. So we are doing a publication on this, but just to highlight the result at the national level, and to say that obviously the SDGs are extremely interesting and extremely useful. But if we look at the aggregated indicator, it's not obviously not enough. It's not sufficient for public policy. One value per country is not enough. But using Earth observation data and satellite data, we can answer questions like how much, where, when, who, so that we can capture the spatial and the temporal dynamics of the country. And one result that we had in Switzerland using the Swiss Data Cube is that we discovered that the value that we generated using the trends.earth model is twice higher than the official value that is reported by Switzerland. And looking at the definition that Switzerland is doing is not in compliance with the UN definition. It's only considering soil sealing. So it's not considering at all, for example, land productivity. So here also we see that that we need to have a kind of common knowledge and common definition, so that if we want to compare land degradation at different scales. In terms of vision, I would say that the Swiss Data Cube is aiming to obviously to support the digital Switzerland strategy, so that we can support innovation and growth. We can support the efficiency, effectiveness of the government investments. We can stimulate research, generate new information product, and facilitate access to data and information to everybody at the national scale. So really our vision, I would say in the next 3 to 5 years, is to not only to be a kind of research infrastructure, but really to deliver a unique capability to track changes across the country and to help all the institutions, not only scientific institutions of the country, to use the Swiss Data Cube to generate evidences so that we can support policy design. A few words on the next step, or the work that we're working on for the moment. So we are working on ingesting all the Sentinel-5P data into the Swiss Data Cube. So trying to develop a workflow so that we can obviously assess the impact on atmospheric pollution over Switzerland due to the COVID crisis. We are working with the University of Zurich to scale up one of the algorithms that they have developed on land surface phenology in the frame of one of the ESA project that they have. We are supporting Armenia and we will launch the Armenian Data Cube in October this year. So based on the knowledge that we acquired here in Switzerland, and we are about to launch a database of national information products such as the NDVI time series, the NEWI, and so on. In terms of challenges, obviously, the interoperability of data cubes are extremely important. So we are working on that. So how we can leverage the potential of standards such as the OGC standards to make Earth observation data cubes interoperable. I mentioned this database already, so this will be the database where we will store all the national products. So it's called the Swiss NVO. And in terms of capacity building, so we have developed this teaching material called Bringing Odyssey into Practice, where people can train themselves to install, configure, and use an Open Data Cube instance. So it's freely available. And this is what we have used to help our colleagues in Armenia to develop the Armenian Data Cube. We have, based on that, we have developed what we have called the Data Cube on Demand. So it's an API that allows users to generate everywhere in the world an Odyssey instance based on specific requirements. So basically an area of interest, a selection of sensors, and a temporal frame, and then automatically it generates a data cube. So the good message also is that we have discussion with the European long-term ecological research project, so that maybe we will test the data cube on demand approach on some of their sites. So that's a positive feedback for us. And obviously, and I think that's the most important thing, is that this data cube technology can really help to go in the open science and reproducible science framework. So if we look at that, obviously we are using open data. All the product that we are generating also from the Swiss Data Cube will be free and openly available and compliant with the FAIR principles. All the notebooks with the algorithms that we are generating are documented and openly available. All the publications are in open access. All the code is on open source, and obviously we have generated this Bringing Odyssey into Practice educational resource, so it's also completely free to use. So to finish my presentation, I would say that obviously EO data cubes are really the potential to enhance scientific accountability and credibility. And without trust and shared knowledge, I think doing science can be difficult. Taking some decisions can be problematic, and envisioning a sustainable development can be really challenging. Especially if we look, for example, at the issue of deforestation in Amazonia, where the President Bolsonaro said that the satellites are generating fake news. That's obviously not fair, and we really need to work hard to convince people that we are generating only evidences of what is occurring on the surface of the Earth. And I will finish my presentation just quoting Albert Einstein, saying that those who have the privilege to know have really the duty to act and to help people. So really, thank you for your attention. If you want to visit the Swiss Data Cube website or follow us on Twitter, you have the links here. And really, I'd like to thank you for your attention, and I'll be pleased to answer your question afterwards.